All right, we are going to start working with absolute value functions. This is a new function for us. We didn't do this in Algebra 1. The absolute value function is going to take this form. And so our very first step in number 1 is to rewrite that as in this form right here. So I'm just going to go through and write it. I'm looking at number 1. I'm going to write it out in this form. And you're probably going to see right away that we have a problem. It's x plus 1 instead of x minus h. So we need to rewrite what's inside that absolute value sign as a subtraction problem. So we're going to write it as a difference of x and negative 1, which is the same thing as x plus 1. You're going to notice that there's no k value written. So just like in y equals mx plus b, if the b value is not written, then it's 0. It's the same in these absolute value functions. As soon as we have it in this form, in the absolute value form, we can answer the questions. Letter A, whether the graph opens up or down. You're going to look at your a value to decide that. All right, if your a is positive, okay, so if you have a positive a, then your absolute value function is going to open upward. If you have a negative a, it's going to open downward. So in this case, we have a negative 1 as our a, and so we know our graph is going to open downward. Identify the vertex. You can get the vertex from this h and this k. So the vertex of these graphs are going to take the values of h and k. The h value will be the x coordinate point and the k will be the y. So you can see that it's really important that we have it written out inside those absolute value signs. It has to be written out as a difference of those two values. All right, so in this case then, we're going to go back. We're going to look at our h value, which is negative 1. So that's going to be our x coordinate point. And then our k is 0. So that will be our y, and that would be the vertex. The vertex is the maximum point in the function or the minimum point. In this case, we're going to have a maximum because this graph is going to open downward. And then in C, they want to know whether the function is wider, narrower, or the same width as the graph of y equals x, the absolute value of x. This is the parent function. So this is what we're going to be comparing everything to. That parent function has an a value of 1. So the larger the a value gets away from 1, so towards that positive side of the number line, the narrower the absolute value function is going to get. So because this one has an a value of negative 1, it's going to open downward, but it still has that value of 1, just like the parent function. It's just the opposite of 1. So this function is actually going to be the same width as the parent function. All right, if we do the same thing with number 2 there, I'm going to rewrite number 2 in this form, and we already have it in x minus 3. We already have it as a form of as a difference of those two values, so we don't have to do anything there. But our k is minus 4, so we want to rewrite that as an addition. All right, so I'm just going to rewrite it down here. We know that minus 4 is the same thing as plus a negative 4. All right, so now we have it in the form that we can answer all three of those questions. Whether the graph opens up or down, it's a positive number. It's a positive 7, so it's going to open upward. It is a 7. So I'm skipping down to letter C, whether it's going to be wider or narrower or the same width as the parent function. Because it's a 7, it's a lot larger than that 1 that a value that the parent function has. So because of that, we know this is going to be a narrower graph than the parent function. Those sides are going to increase steeper, faster than the parent function. So you're going to end up with a tight, narrow absolute value graph as compared to the y equals absolute value of x. And then the vertex, we're going to go in and grab our h value for our x coordinate and our k value for our y coordinate. And so we would end up with 3, -4 as our vertex, and that is going to be a minimum because our graph is opening upward. That 3, -4 is the minimum point on this graph. All right, let's move down to number 5. All right, so my a value is -2/3. I'm going to rewrite the inside of the absolute value sign as a difference of those two values. And then again, the k is not written, so we know it's 0. So now we have a negative a value because we have a -2/3. It's going to open downward. 2/3 is a fraction. So we're just looking at the absolute value. That we've already decided that the negative sign makes it open downward. Now we're looking at the 2/3. 2/3 is less than 1. Anything less than 1 for an a value is going to give us a function that is wider than the parent function. Remember again, the parent function has an a value of 1. So once we go less than that, we're going to start getting functions that grow wider. The sides rise a little slower. Then we've got our vertex. We go in and grab our h and our k, and we end up with -1, 0 as our vertex. And this again is the same as the number 1. It's going to be our topmost point because it's going to be a maximum, the vertex, because this graph is opening downward. All right, number 8. One more time, rewrite these as an absolute value. Here I had to rewrite that x plus 3 as a difference of those two values, x minus a -3. And now I have a -9. I need to rewrite that as a sum. So -9 is the same thing as plus a -9. Now I have everything I need to go in and identify everything with those A, B, and C questions. All right, so we've got a positive 7/8, so we know it's going to open upward. It is 7/8. 7/8 is a fraction that is less than 1, so we know that this is going to be wider than our parent function. And we can see that our vertex then is -3, -9. That's going to be a minimum because this graph is going to open upward. That vertex is going to be the lowest point on this graph. Okay, now in number 10, we're going to actually go in and graph the function. So let's rewrite that as, I'm in number 10, but I'm going to rewrite it so that it's in this form again. Okay, I'm going to rewrite the form. All right, so y equals the absolute value of x. All right, so our a value is 1. There's nothing written in there, so we know it's 1. We don't have an h value. We don't have an h value recorded, so we know it's 0. And we've got a k value. We need to rewrite it as a sum. And so we're going to change -3 into plus a -3. All right, so the vertex is, for this one, is 0, -3. We know it's going to open upward. And we know it's going to be the same width as the parent function because the a value is 1. So I'll graph the bottommost point. Okay, that's the minimum. That's your vertex. And then that a value is functions like our slope. So because it's 1, we're going to go up 1 to the right 1. All right. And then because it's an absolute value function, the mirror image of those points is also going to be part of the function. So I'm going to go back on the other side and I'm going to graph those mirror image points. Right, and then you connect the dots and you've got your absolute value function. Do the same thing with number 11. So on number 11, we'll rewrite it. All right, we can see that we have an h value of 3 and we have a k value of 0. So we can see right from there that our vertex is going to be 3, 0. We can see from our a value that that is positive 1, that it's going to open upward. And so I'll go in and put my vertex at 3, 0. And because the a value is 1, I'm going to go up 1 over 1, and do that a couple of times. And then this right here is that vertex is where that mirror kind of runs through. That's the axis that we're kind of reflecting over. I'm going to take in those points that show the mirror image of those. You don't need to draw on that dotted line there. You really probably shouldn't. I just wanted to show you where that mirror reflected mirror is running through the vertex. And then you connect your dots and you've got your function. On 12, we rewrite that inside the absolute value signs as a difference of those two values. And then we've already got it as plus k. So our vertex is -2, 1. I'm going to go ahead and plot that. And then our a value again is 1, so we're going to go up 1 over 1 a couple of times, get a few points in. This is the mirror right here running through that vertex. And so I'm going to go on the other side and take those mirror image points and then connect the dots. Okay, then moving down to 16, they want you to write an equation of the graph that is shown. So we need to know our vertex, and we need to know what our a value is. So if we're looking there at 16, we can see that our vertex is -1, 2. We can see that our graph opens upward, so we know our a value is going to be positive. And we can take two of those points. I'm going to take the vertex and this point right here, okay? And I can count up and over 1 and see that my slope is 1. So because it's positive, the a value is positive because it's opening upward, and my slope is 1, then I know my a value is 1. So I can rewrite or write an equation of that graph using this form right here. Okay, you're gonna leave a. I'm sorry, I should have an a right here. A is 1, so we don't have to write anything in there. And then my h value, my x coordinate is -1, so I'm gonna just write it in first and then we'll simplify it. My k is 2, so it's already positive. I go back in, change those signs just to simplify, make things look neater, and that would be your equation for that graph right there. Would do the same thing on 17. My vertex is right here, and that is at 2, 3. All right, so I'm going to take that point, and I'm going to take this point right here on the graph. And I'm going to figure out my a then. So to go from one point to the next, I'm going down 2, and I'm going to the right 1. So that shows me that my a value is -2. All right, it opens down. That makes sense. So now we've got everything we need. We're going to rewrite, and this time we're going to replace a with -2. My h value is 2. Oop. And my k value is 3. And there's the equation for number 17. In 19, they want you to sketch the function x plus 2. So they're calling it f of x instead of y. So I went in ahead and sketched in that linear graph. And then they want you to sketch the function y that they're giving you, given by the transformation to f of x. So they're telling you that they're taking that f of x that I just graphed, which is x plus 2, we can call it f of x, or we could call it x plus 2, and they want you to transform it 1 unit vertically. That's what that plus 1 means. So if I were to plug that in to show you, it would be y equals, instead of writing f of x, I'm going to go ahead and write in the x plus 2, because that's what f of x equals. That's what they gave you up there in the directions. And then they want to add to that plus 1. So what that really comes out to is, instead of moving that line up just 2, that linear line up 2 units vertically, you're moving it up 3. Right? So if we were to graph that, then it would just be 1 unit up. Every point that's on f of x would be moved up 1 point vertically. All right, and then you have f of x plus 1 in green. So it's the same line as f of x, we're just transforming it. That's the word, the math word, to indicate that we're moving it vertically 1 unit up. We can do the same thing in number 20. If we sketch in, again, f of x equals x plus 2. Oh, I'm sorry, no, f of x equals x, x plus 2. I'll do that again in red. Right, so this is the same one that's in red over on the other side. There's f of x. And then they want us to graph y equals f of x minus 2. So if we plug that in, our f of x is x plus 2 minus 2. We're going to end up with y equals x. And that is the linear graph that runs right through the origin with a slope of 1. Right? So they're just comparing it to that function. Now for 25, they are giving you a word problem about the number of boats that a boat dealer sells in each month of the year, and they're modeling it with that function b equals negative 15. Okay, and so b is the number of boats sold, and t is the time in months. And they're asking you to just remember that t of 1 is going to represent January. That's going to help you answer some of the questions below. If I rewrite this in with the values that we've been looking at, that's going to look like this right here. Okay, this is written in absolute value form. You have to be able to recognize that in order to make use of it. Our vertex then is going to be 5, 120. That's our vertex. Our a value is that negative 15. So a equals negative 15, which means our function is going to open downward. So we can go in and we can plot our vertex on this graph at 5, 120. So that's month 5. Boat sales were 120. And then from there, you can use that negative 15 to plot some of the other numbers. So go ahead and pause the video and try using that slope to get some more values in, and then start it up again. All right, so I used that negative 15, and I went from the vertex down 15 and over to the right 1, and I ended up at month 6 with 105 boats sold. And then I did that again. I went from the 105, I went down 15 units again. That took me to 90, a y of 90. So that's 90 boats sold. I go over 1 month, and that is in month 7, right? Because that month 5 is our vertex, there's a line of symmetry running down there. It's like that's where the mirror is. And I could reflect these points that I had already graphed over here. I didn't have to do any more math. I just knew that the point that was going to be reflected over that line of symmetry, I'm going to reflect it over, it's going to take me to month 4, and it's going to have the same y, that 105. I did the same thing. Here's the axis of symmetry. I had plotted 7, 90. I know that the mirror image of that is going to be over here at month 3, and it's going to have the same y value of 90. And so that's how I got those few points, and then I was able to connect the dots to finish off my graph. Then on 26, we can use all this information to answer 26 and 27. What is the maximum number of sales in 1 month? Well, that is our vertex. That is the maximum point, that vertex, because it's opening downward. The maximum point is that 120, that 5, 120. That's our vertex. So in month 5, which if we go back up here and we see that they told us that t equals 1 is going to represent January, then if month 1 is January, that makes month 5 May. All right, so in May, there were 120 boats sold. That's the maximum. 27 asks for the minimum. What is the minimum number of sales in 1 month? Well, you can look at our graph and see that as this side descends, it's going to go all the way down into month 12. They don't have month 12 written there, but if month 12 were written there, we can see that would be our lowest point. Okay, it almost looks like it's going to be 0 boats sold. So that's a good place to go in and actually take 12 and evaluate t of 12 and see what you get, because the graph, especially the way we have it written, is a little bit, it's a little unclear. We can't exactly read it from there. So I went ahead and did that math. I plugged in 12 for our t. I got the function from up here in the word problem. I plugged in 12 and I got 15. So that means in December, there were 15 boats sold. Okay, the mirror image of that point for number 12 is actually off the graph. You can see over here, we can't, anything past 0 months, which if this line right here kept going, it would be into negative months. That doesn't make any sense with our word problem, and so we just disregard those values. That's how we know over here this is the lowest point on our graph, is that December, the month of 12.